Today we're going to talk about good old E and natural logs. It's been a long time since you dealt with E and natural logs, over a year for most of you. You learned this first semester of pre-calc. So we might do a little review with the properties of natural logs, and then eventually we're going to talk about how to do the derivative of functions containing E and natural log. Zoom in a little bit here. One bit further. So what I've got up on the screen right now for our launch is just some properties of natural logs. Just a review. Natural log is nothing more than log base E. And you can pause the video and write these in your notes. Ideally you've had these before. This is going to help you a little bit on the homework if you can remember some of these properties. Alright, moving on. I want you to use the properties from the previous slide, and from last year's class, to evaluate. Natural log and E are inverses, so they cancel each other out in the first one, and our first answer is just 2.5. It's that easy. For the second one here, I'm going to rewrite it as the natural log of, again, using our exponent rules, it's E. There's a square root, so it's 1/2, but it's in the denominator, so it's negative 1/2. And again, we know that natural log and E are inverses. They cancel each other out, so I'm left with negative 1/2. Part C, E and natural log are still inverses. They cancel each other out, and there's 7. There's a longer way to explain that, but that's really the short version. And then I get here, E, and then I have it to the negative 2 times the natural log of 4 power. The E and the natural log are not right next to each other. They can't cancel each other out. So let's focus on what's in the exponent. The exponent says negative 2 natural log of 4. We have a natural log rule that says if you have a log of a power, you're allowed to bring that power out front, that exponent out in front. So we can do the reverse. We can take this and bring it back as an exponent and think of this as E natural log of 4 to the negative 2 power. Well, once again, E and natural log cancel each other out, so we're left with 4 to the negative 2 power. Negative tells us to do the reciprocal, so we have 1 over 4 squared, and I'm looking at 1 over 16 as our final answer. Is that as easy as you remember logs and E being? I hope so. Now let's get on to the calculus, the derivatives. Derivative rules for the exponential E. If you've got a function y equals e to the x, you're going to like this one. The derivative of that function is e to the x. Pretty amazing. I'm sure it has something to do with the special properties of E, but I don't know much beyond that. But most of the time you aren't just dealing with e to the x, you're dealing with e to some stuff. So then you have to do the chain rule. The derivative of e to some function, or the derivative of e to some stuff, is still equal to e to some stuff, but then times the derivative of that stuff. That's just chain rule. So really this whole line here is kind of unnecessary, as long as you know that the derivative of e to the x is e to the x. And now if you start putting a function in place of x, you have to do the chain rule with that function. Natural log. The derivative of natural log is, or natural log of x, is 1 over x. And once again, if you have the derivative of the natural log of some function or some stuff, it's going to be 1 over that stuff times the derivative of that stuff. So let me rewrite this one here. Derivative of natural log is 1 over x, so if I have natural log as some function, it's going to be 1 over that function times the derivative of that function. So 1 over the stuff times the derivative of the stuff. And then when you multiply those together, multiplying fractions is easy, and you end up with the derivative of the stuff over the original stuff, or the derivative of the function, that you were taking the natural log of divided by the original function that you were taking the natural log of. All right. So, using those notes, see if you can find the derivative of a through e. A says y equals e to the 3x. B says y equals e to the x plus 2. C is y equals e to the negative 0.5x. D is y equals x divided by e to the x. And E, y equals the square root of e to the 2x plus 10. You're going to have to use all the rules we've had in the past. I'm going to see if I can make this just a little bit bigger for you guys to see. Let's take about, you might need as many as like 8 or 10 minutes to get this one done, maybe even more. So pause the video now and evaluate in a little bit. All right, let's go through this together. This first one is all about the chain rule. We've got y equals e to some stuff. Well, the derivative of e to some stuff is e to that same stuff times the derivative of that stuff, and the derivative of 3x is 3. So we have a final answer of 3e to the 3x. Part B, you've got two different functions being added, so you take the derivative of each of them individually. E to the x has a derivative of e to the x. 2 has a derivative of 0. The next one, we've got e to some stuff, so that becomes e to that same old stuff, negative 0.5x, times the derivative of that stuff, which is negative 0.5, just like we did over here with the 3, and then you can clean that up to negative 0.5 e to the negative 0.5 x. Hard to believe Mr. Peacock wrote a problem with decimals in it. Part D, that's looking kind of like chain rule maybe, or you could think, not chain rule, I'm sorry, quotient rule. You could probably also do this one as product rule. So let me clean this whole thing up and we can focus on just those problems there. So if we're going to go with quotient rule, we've got our u, we've got our v here. You could also rewrite this though as x times e to the negative x. And if I'm not mistaken, I bet you guys like product rule a little bit better than quotient rule. So let's do it that way. Let's do x times e to the negative x as our original function. That would mean that our u is equal to x, u prime is just going to be equal to 1, v is going to be equal to e to the negative x, and v prime is going to be equal to e to that stuff times the derivative of that stuff, which is negative 1, or negative e to the negative x. Alright, so then we put it all together with our product rule. Y prime is equal to the derivative of u times v plus u times the derivative of v. And we end up with u prime being 1, so I don't even need to write that down. V is e to the negative x plus u, which is x, times v prime, which is negative e to the negative x. I don't like how that looks. Let's bring the negative out here, so we'll have, alright, so we've got e to the negative x minus x times e to the negative x. I'm okay with that as a final answer, but I'm also looking at this and I notice they both have e to the negative x. We could factor that out. We'd have e to the negative x times, there was only one e to the negative x there, and then over here there was minus x times e to the negative x. So either one of these is nice. This is all simplified. This one's factored, which makes it arguably better. Alright, and that was for problem D. Let's now take a look at problem E. Alright, for part E, we've got to use the chain rule. You've got some stuff that's getting square rooted. You can rewrite this as e to the 2x plus 10 all to the 1/2 power. Your stuff is right here. Let's call that u. U equals e to the 2x plus 10. So u prime is equal to e to the 2x times the derivative of that stuff. The derivative of 2x is 2. I'll throw it out in front. And the derivative of 10 is 0, so we don't need that at all. So we kind of are doing chain rule here, and I did chain rule within chain rule, because e to the 2x, e to some stuff, stays e to some stuff times the derivative of that stuff, which is 2. Alright, then the big picture is taking all of that stuff, all of u, to the 1/2 power. If I want to find the derivative of that, so again, y was equal to that. So then the derivative of this is going to be equal to 1/2 u to the negative 1/2 power times the derivative of u, which was 2e to the 2x. I want to get rid of my u, so I've got y prime is equal to 1/2 times whatever u was, which was e to the 2x plus 10, all times, to the negative 1/2 power times 2e to the 2x. Alright, let's see if we can clean some of this up. So I've got a big fraction bar, y prime is equal to that. I've got a 1 in the numerator, a 2 is in my denominator. All of this is in the denominator since it's negative, and since it's to the 1/2 power, that's all a radical. So I've got e to the 2x plus 10, all hanging out there in my denominator. All of this goes in my numerator. That's 2 over e to the 2x. I notice there's a 2 in both the numerator and the denominator. Let's cancel those out. So I have the derivative is equal to e to the 2x all over the square root of e to the 2x plus 10. That's a good one. So for example 3, we're dealing with natural log. Remember that the derivative of natural log of x is 1 over x, and then we need to use the chain rule if there's any stuff that we're doing the natural log of. Only a few examples here, A, B, C, and D. Let's take about 5 or 6 minutes. You can pause the video now. Alright, let's go over these together. Y equals the natural log of 3x. So the natural log of some stuff, we have the derivative of the natural log of that stuff is 1 over the stuff times the derivative of that stuff, also known as 3 over 3x, but those 3's cancel out, so I have 1 over x. Part B, I've got 3 minus 2 times the natural log of x. Well, the derivative of 3 is 0, so that's gone. Remember, any coefficients we have all the way back to our first lesson on the shortcuts, those just stay there. We don't do anything with them. They're just hanging out. So we have negative 2 times the derivative of the natural log of x, which is 1 over x. There's no stuff involved. Now we just multiply those together, and we have negative 2 over x. Alright, I'm going to clean up the board here. This next one, we have a little bit of chain rule going on. We can rewrite this as natural log of x to the negative 1/2 power. You could probably use quotient rule here as well, but I think this is going to be much easier. So we've got some stuff to the negative 1/2 power. So we're going to let u equal that stuff, natural log of x. The derivative of u is 1 over x. And let's look at the big picture. The big picture is y is equal to u to the negative 1/2 power. The derivative of that is going to be equal to negative 1/2 u I'm sorry, there's no 1/2 involved in this one. Let's start once again. So this is just to the -1 power. I'm sure you already corrected me on that. Which will make this problem a lot easier. Alright, so u to the -1 power is my big picture, all of that being taken to the -1 power. The derivative of that is -u to the -2 power. Times the derivative of u prime, which is 1 over x. And so, we're going to get rid of our u's here. We'll have y prime is equal to negative natural log of x to the second power, negative second power, I'm sorry, all times 1 over x. Those of you who may have tried this with quotient rule, we start to see, okay, there was our v, our denominator. It's going to end up being squared at some point. The negative says it's going in the denominator, so we should end up with a very similar answer, ideally. And so let's write our final answer here. We've got a negative sign, we've got a division bar. This is a negative exponent, so natural log of x is going down there. We'll square it. We also have an x down there. So 1 goes up top, so -1 over natural log of x squared times x. Or if you put the x in front of that, that's fine as well. D is not as challenging as the one we just did there. We've got y equals natural log of x to the third power. Chain rule, once again, is what I'd go for here. So let's let u equal natural log of x. U prime is going to be equal to 1 over x. Y is equal to u to the third power. The derivative of y is equal to 3u to the second power times the derivative of u. Just write it that way and then do the substitution in a moment. So we end up with y prime is equal to 3 times whatever u is, which is the natural log of x, to the second power times whatever u prime is. Let's make sure that looks like a prime and not a 1, which is 1 over x. And I think we can make this look a little bit better. Let's put all the stuff in the numerator there. So we have 3 natural log of x quantity squared all over x is our derivative. All right. So 2 pages here. One is dealing exclusively with e's, one's dealing with natural logs. Page 375, 1 to 3, and page 377, 1 to 3